will, again, what happened is we have three entities here. Okay, the first entity, guys, which is your browser. Okay, the second entity here is the bank that you are dealing with it in a day-to-day basis. Okay, so what happened is you will authenticate to the bank. You will get a cookie or session cookie. You are authenticated now. Now, in order this attack to happen, you really need to visit a website that's really owned by the attacker. So the attacker will maliciously trick you, okay, using social engineering or phishing attacks or whatever to visit his website. What is inside his website? So your browser saying get request to his website, and in his website he have a nice image here, or maybe there is no image at all. You cannot even see it because he can control the size of this image, and your browser will be rendering this image. What inside this image is a command. What is the command is saying? Go to bank, which is your bank. Okay, go to a certain fund basically page. You will go, okay, and in this page, do the following: add to from a query string or a number, which is this one. Add to this is query string, and this is basically an account number owned and controlled by the attacker. And then amount, okay, this is the attacker what will specify according to how much you have in your bank account. Maybe 5,000. If it doesn't work, he will make it less, or maybe he will make it high again. Then date, he will specify the date. How did he get all these numbers, and how he crafted this specific request? Again, because he studied the bank.com is in a very good manners. He studied how the transfer fund page looked like, and when you go to any website, guys, and hit continue here, in the URL up there, it will show all the query strings and all the values in the query strings. So the attacker is good in this. Even if it doesn't show you and shows you, dollar signs and all this other stuff, this is called encoding. So he can really encode his request to look exactly like how this website looks like. Okay, guys? So this is basically what's happening. I hope this is clear. Attacker website has an image with an above tag. This is a tag. The image forces the user browser to forge request. And again, that is why they called it cross-site forging request, because this specific image will force the browser to forge a request with a specified URL, and the customer logged into the bank, money will be transferred from this account to this account. Okay, guys? So far, so good. I'm just trying to simplify how CRSF are done. Okay, so now if you say yes, how about the risk, guys? Is it too early to explain all this, programming stuff? Okay, maybe inshallah. That's why I didn't want to really go for really, actually we were gonna talk about basically Windows specific attacks, and this Windows specific attacks, the overflow requires a lot of programming. So I said, let it make it on Sunday when everyone is really fresh. Okay. Again, the forge request is a GET request with a body similar to the post request, and this will be executed in the attacker website. And this is how it works, guys. If you wanted really to see how it works, again, you are authenticated to this website, and then when you are trying to transfer money, okay, okay, when you this is the normal transfer money. This is the transfer page, okay. And when you are trying to transfer money, so you will transfer money normally. You will do post from this website, sorry, this account to this account, and this is the amount, and will be executed. Okay, but again, when you browse to the evil.com, and what the image will be loaded, and the image will be basically saying, you know what, I'm gonna move this amount from this specific account, which is your account, to the attacker account. And again, guys, this is the amounts over here, and this is the date, and here is the last thing, which is recurrence or no is not. This is force the victim browser, this browser, which is your browser as the victim, okay, to go and ask get request from this specific page and then execute this mode. Okay. One of the problems that we can really tell here, guys, is basically the website here, guys, doesn't really differentiate between post and get. And this is really issue. And that's why yesterday I wanted really to explain the difference between get. Get, you are getting information. Post, you are posting information. One of the reasons that this attack managed to really go through, okay, is basically is your website doesn't really specify what kind of request it will be accessing your transfer executed website. Okay, so if you mention clearly, I want a post request. Post means I'm uploading. I don't know if you know a little bit about web programming, but again, in web programming, if we have a form, okay, we usually, guys, when we post the data inside this form, especially if we are filling data in this form, when we hit enter here or the submit button here, it should post this information to the website because I'm really sending data to the website. Okay, if I said get, it will work, but again, I can specify here in the website I only wanted post. I can specify here in the server side it's an only post request. I don't know if you have studied PHP or no. You can specify what kind of data you will get. You will get a post data and save it as variable here in the URL, or you will get data. Okay, so what one of the reason here that I didn't really in the server side of this website didn't really specify post. So when I get a post, I execute it, and this is an original post. This is coming really normally from the user to this website, but this is get are coming from evil.com to get this page. Okay, but inside this get the page, we have also data here. So he dealt with posts as get, and this is what's wrong execution. So that's why early beginning of how to really stop this CRSF attack, that you don't really get a request here, you only allow post requests. Okay, guys, do you understand what is get and post? But how did get this really came from? Get came from the guys why when we have an image here and this image are rendering in our web page, okay, it will try to go and get the image, okay, but inside the get the image we have all this code over here, so it will transfer the image to get request, and this get request will be sent to our transfer.cgi. Okay, guys, we understand what does that mean? Hello? If you wanted me, guys, to really explain it one more time, is okay. I don't mind at all. But I'm just saying this is the difference between post and get. And again, post, we are posting data to the website. Okay, how we get end up with get here? Because when the image are rendering here, or maybe they are executed here in your browser, it will initiate get to whatever is the source of the image. Okay, whatever the source of the image is basically the transfer page here over here, and that's why this command is executed in the background. And by the way, if this image is just very small, you cannot see it, you will not even see what's happening in the background. So this is another thing that the attacker are really good at, is to hide this image somewhere in the page, because he don't want you to see this an image it failed to execute. So this is another thing that you really need to find about. Yes, exactly. Yes, exactly. It's good to really remember how to really handle the post and get request. So one of the really early attacks mitigations is how to really really specify here that I wanted only post messages and not get messages. I think if I showed you how the code will look like, you will remember this. Just give me 1 second. I'll just go here, show you how the difference between post and get. And that's why I wanted really yesterday to explain the difference between post and get. To stop get and allow just post. Allow just post. Yes, this is the early beginning. Okay, but the attacker have a way to really manipulate this as well. I will show you guys, but just give me 1 second. So we post in PHP code. Okay. Okay. So this is PHP post request. Okay, exactly, Ashaza. So that's why we don't use get. And this is again here, this is a form that I was telling you guys that when we have a form, we usually specify here the method is post. Okay. And again, in the server side, okay, we request method as a post. Okay. If we done this, this is at least will stop the attack. Okay. Unless the attacker will manage to convince us to do a post request. But again, it's not easy. But what I'm saying is, with doing this specifically, that's our form should be post, and our how we handle the data in the server side with a post request, this is can be mitigated. Okay, so this is just to show you how what is the difference. So get is less secure in from post in this specific thing, and also there is a difference between guest and post, guys, in the URL itself. In the URL, when you using get, the get data will be showing in the URL here. Okay, if we using post, it's not going to be shows. What I mean by this, guys, and this is again something maybe you studied for whoever studied web programming. When you are using a method here, get, okay, anything that you're gonna hit after you submit here, when you click submit, it will be showing here as a query string in the URL. So your URL over here in the browser, okay, will be showing. And again, we can do this also as an exercise, okay? But when you do the same thing with post, this data will not be showing here in the URL. Again, why this is more secure? Because I don't want anyone standing beside me, or maybe he is analyzing how this request is done to show, okay, basically the URL data here. Maybe my account is over here. Maybe a session ID is showing here. Okay, I don't want anyone to see this. So that's why another difference between get and post. And again, we are not recommended to use get in this specific reason. So we really need to work with post. Okay. So I'm gonna go back here. I'm gonna go and when I'm malicious, this is basically necessary action to take in place. User must be capable to execute an unwanted action on a trusted website, have an implicit authentication. So this is basically, guys, are listing all the conditions that need to be in place in order for this attack to take place or to happen. Okay, so the user must be capable of executing unwanted action on a trusted website. So we have implicit authentication, means you or your browser is authenticated to your bank.com. Okay, so this is one thing. Other thing that's also is need to be there is you visit the bad website. Okay, the trusted website only check that an action come from an authenticated user browser and not the user itself. Okay, what we mean by this, if you are requesting transfer, okay, your browser is sending me a transfer, but you as a user who is sitting on this browser, do you know that your browser are really asking for transfer? And that's why multi-factor authentication here, guys, will come into play. Why? Because basically I got a request to transfer. If I didn't verify with you, okay, so that means the bank.com is trusting your browser. So your browser, if said yes, yes, no, no. So if you allow me in this to explain this is again, back to what we have learned in preventive techniques. So once you get a request to do something important as transfer, okay, how did I know, okay, if you are someone here is smart and who is a little bit knows about security, maybe this guy is being phished, or maybe this is an impersonated person who managed to steal his cookie, or maybe this is his browser being tricked by cross-site request 4G. Okay, I need to know if the browser are really saying this, or the user who is controlling this browser is saying this, okay? Or maybe an attacker who's using this browser who is really behind this. How can we really stop this, guys? By implementing verification, okay? And the verification can be done by what? By saying, okay, you requested this amount, you need to give us an OTP. We're going to send you an OTP to your mobile, and OTP, once you get it, you will be able to do the transfer. So if the attacker are doing this, he doesn't have your mobile, he will not be able to send the OTP. If your browser are doing this, okay, you'll get a notification on your phone and you said, okay, I didn't really do anything. And that's why a lot of banks right now, guys, are implementing OTP. Why? Because he wanted really to stop the attacks that comes as a cross-site scripting, which is XSS. Someone has already your cookie and managed to steal your session ID, or to stop that your browser are doing something on behalf of the attackers, which is basically the cross-site request forgery. Okay, so that's why a lot of I don't know if you have a banking account, but a lot of banking accounts will require now before a transfer, or even sometimes before you check your bank balance, to really get a password like an OTP in your file, or maybe a double factor authentication, maybe a fingerprint or something to authenticate what you're doing. So this is the reason behind the two-factor authentication. Okay. Also, one of the conditions that really require for this attack to take place, and I mentioned it at the beginning of the lecture, that the user must be socially engineered to visit a malicious website during the authenticated session with the trusted website. So this is definitely a condition. Why? Because this is the only time when you visit this website, he will run here a frame, or he will run a picture here, and when you render this picture to your browser, it will generate a request to the original website. Okay, so if you didn't really visit him or website, or maybe he didn't really send you a link, or maybe send you a page visit, this is will not be this attack will not take place. So this is, I would say, it's a combination of social engineering and technical engineering as well. And again, it's targeting a lot of financial systems, and that's why a lot of banks right now, they are really pushing into two-factor authentication. Yes, well, it's harder than ever before, okay, but it's more secure, unfortunately. يعني they're always I'm telling this is what I always tell even to my boss sometimes, and I talk, there is always, and he is always telling to remind me, there is a triangle here, okay, and the triangle is saying ease of use and security, okay, and you need to be balanced, because if you make it very easy, okay, you can see attacks like this happening in the background, okay. If you make it very hard, okay, for someone to log in, people will start to really hate you, and like what Naif is saying, okay, and they will try to find ways to circumvent your security, okay. So maybe if you make I will just give you an example. If you make your password 20 characters, okay, so no one will remember 20 characters, and especially if you don't teach them how to create a strong password. So what will happen is they will end up writing this